Hey people, good evening. Nirvigna, Sridhatri. Good evening. Are you able to hear me?
Yes, ma'am.
Yes. Okay, great. So I'm sorry for being late. I was stuck up in 10th class session. Okay. So today our goal is to complete exercise 1.2. But before that, I would like to ask, do you have any doubts in exercise 1.1?
No, ma'am.
No? Everything is clear? Okay. So Rahi is not here still. So exercise 1.2. Ready with your notes?
Yes, ma'am.
Great, beta. Chalo, let's begin. Before I start, I just want to ask you, you can suggest this to your friends also because the number is very less in the class. You can ask your friends also to join if they wish to. Okay? So, depending on your feedback. And also, I wanted your feedback in WhatsApp. So, I did not receive any feedback from this batch. Yes. So, please do share me your feedback. Got it? Today, I require your feedback. So, let me see what can be done. Okay? Depending on your feedback. Chalo, so 1 second. Yes. So yesterday we have completed exercise 1.1, which was dealing with yes, which was dealing with number system basic things, and we also learned how to insert between any two given numbers, insert rational numbers between any two given numbers. Now I'm going to give you a small test. Okay, within 5 minutes, not even 5 minutes, within 2-3 minutes, you can complete this. So you should complete and let me know. Okay. So question is, 1 second. 1 second, beta. Yes. Question is insert. What happened? Insert six rational numbers between 2 by 5 and 3 by 5. Come on. I'll give you 2 minutes. Finish it off quickly and let me know.
Ma'am, I'm done.
Great. Okay. Rahi is doing
Ma'am, I'm done.
great. So, who would wish to explain this? Come on, any one of you. You can tell me the procedure how you have done. Okay? Yes. Display your answers first of all. Display your answers. Let me see if they are correct. Okay, cool, cool. Very good. Well done. Well done, people. So basically six rational numbers. So I'll have to take 7. So I multiply 2 by 5 with 7 and 3 by 5 also with 7. Multiply and divide. So I get 14 by 35 and here 21 by 35. So between 14 by 35 and 21 by 35, I have 15 by 35, 16 by 35, 17 by 35, 18 by 35, 19 by 35, 20 by 35 and 21 by 35 is anyways there here as the extremes. Oh, these are there as the extremes. So 1, 2, 3, 4, 5, 6. So 6 rational numbers are done. Okay, this was only one model which we learned yesterday from exercise 1.1. Now today we are going to extend the topic a little more and learn about real numbers. Okay, yesterday do you remember we have learned natural numbers? Then we said if I add 0 to natural number, I get whole number. Then I said if I add negative numbers to whole numbers, I get integers. Then also we discussed if we are taking numbers in the form of p by q, I get rational numbers. Only condition is q should not be equal to 0. Okay, till here we have learned yesterday and we have discussed various conclusions from this. Right? So today let me tell you one more important thing. These rational numbers are also a part of real numbers. A bigger set called real numbers. Okay, and here you have one more different set called q dash. Can you tell me what is this now? Q is rational number, as you know.
Irrational.
Very good. This is nothing but irrational number, the opposite of this. Okay, since both are opposite of each other, they cannot overlap, so they has to be separate. Are you able to understand? So the number which is rational cannot be irrational. The number which is irrational can never be a rational number. Okay, they are opposite to each other, so no overlapping. But these two numbers together, all these numbers together, we call them as real number system. Okay. Apart from real number system, there is also one more number system called complex number system, which you will be learning in your +1, +2, I guess. +2, I guess. Okay. So as of now, we are learning only confined to only real numbers. Got the point? Okay. Right. So what are real numbers? Rational numbers plus irrational numbers will give you real numbers. Now, why did I say only rational? Because this natural, whole, integers are all part of rational only. So I can simply say the entire family of rational number plus the irrational number will give me the total real number. Can you see it on the screen? Are you able to understand now? So simply I can say rational numbers plus irrational numbers will give me real numbers. And as you can see, rational and irrational are completely opposite to each other. Got the point? Yes? Okay. Now having said that, now what are the examples of irrational numbers? Examples of irrational numbers. Rationals you know now. Oh,
Mom, root 2.
very good. Very good. So root 2, which I've heard earlier also. This is an irrational number. Okay. And pi, which you use it always, is an irrational number. So root 3, irrational number. Root 5, irrational number. So in general, I can say root of any prime number. Okay, you take a prime number, take the square root of the prime number, that will be an irrational number. So all these are examples of irrational numbers. Got it? Okay, these are some examples. So we will extend the concept further also. So examples, did you understand? Okay, so in this exercise 1.2, we are basically going to locate these irrational numbers also on the number line. Okay, now the line which you have been drawing is called real number line. Okay, this is called real number line. Now when I say real number line, which means it includes rational as well as irrational. Got the point? When I say real, it is rational and irrational also. Okay, so when I say real number line, so this line is a home for both rational and irrational. Okay, so in simple, again I can conclude that here on this real number line, you can locate any rational number. Okay, you can locate any rational number. Like yesterday in the examples in the concept, I told you 0, 1, 2, 1 by 2, 1 by 4. Any rational number you can locate. Infinite rational numbers. Also, irrational numbers also have a place, right? Because this is also a part of the family of real numbers only. Okay, when I say real number line, it is a line which has space for both rational and irrational also. Okay, you know how to locate rational numbers on the number line. You have learned how to locate rational numbers on number line, I think in class 8, I guess, if I'm not wrong. Okay, so you know how to locate rational number. Now, here we are going to learn how to locate irrational number. Got it? So, always remember on the number line, okay, every number has a particular point. Okay, every number can be located through a particular point on the real number. Okay, and every point every point has a particular number. It could be rational or it could be irrational, which means suppose if I take a number root 2, as we have seen here, root 2 you can locate it on this real number line. Okay, that is what I mean. And if I take a point, suppose here I am taking a point. So this point will correspond to some number definitely. That is what I mean. So if I take a point, I should be able to associate some number to it. If I take a number, I should be able to fit the number somewhere on the number line. There will be a point where I can fit the number. Are you getting the point? Okay, so all real numbers, in simple words, I will tell you now. All real numbers can be located on this number line. Got the point? All real numbers you can locate on the number line. So real numbers, by which I mean rational and irrational also. Okay? So you have learned in your lower classes how to locate rational numbers. So we are not worried about that. Now we are going to learn how to locate irrational numbers. Clear till here now? Yes? Okay? So if you just open your exercise 1.2 before locating the numbers, I just want to complete the first two questions. So just look into exercise 1.2. As we discuss the concept, it will be easy for you to complete these first. Every irrational number is a real number. Is it true or false? Every irrational number is a real number. You can see here an answer. Every irrational is a real number. True or false?
True, ma'am.
True? Great, beta. Every irrational number, all these are irrational numbers. You can see all these irrational numbers are all real numbers. Yes? So it is a true statement. See the next one. Every point on the number line is of the form root m, where m is a natural number. Every number on the number line is of the form root m, where m is a natural number. First one was true. Second one, they are saying every number on the number line is of the form root m. For example, if I take a number 4, I can write 4 as root 2. Okay, if I take a number, say 6, say 9, I can write it as root 3. So every number they are saying you can write it as root of some number, where this inside number is a natural number. Okay, not negative number, no integers here allowed, only natural number. Is it true? I can also take root 2 here. I can also take root 3. Yes? Can you find the space for every number on the number line? We have learned here. We know that we have space for everyone. Okay, we welcome everyone. Whoever belongs to the family of real number, we welcome them. Okay, into the number line. Do we? Yes. So here also the same question, they are just twisting it and asking you. They are saying that every number, whichever it is, in the form of root m, where m is a natural number, I can accommodate it on the number line. So the answer will be true. The answer will be true unless and until it is a natural number. Here, this m should be a natural number. That means it could be 1, 2, 3, and so on. If it is a negative number, can you tell me root of a negative number? Suppose if it belongs to integers, root of a negative number, is it defined? This is undefined, or I can say instead of undefined, let me use a better word for this. Let me say this does not belongs to, let me say this does not belong to real number. Then when it does not belong to real number, so I told you the other part of the universe, I said real numbers opposite is complex numbers, which we'll be learning later. So this actually belongs to complex numbers, okay, iota and all, which we'll be learning later, but not real number is our present concern now. Okay, so which means when I say this root of m, if it is a natural number, then this will belong to a real number, and everything which belongs to real number can be represented on the number line. When this m under root of any, here we have taken it as m, if it is integer, then it could be negative number also. So when it is negative number, it doesn't belong to real number because it comes under complex number. So complex number has no space on real number line. Okay, it is completely opposite. Understood the point? Okay. Anyone, can you explain me this? What did you understand in your words? Nirvigna?
Yes, ma'am.
What did you understand better? Can you summarize?
Yes, ma'am. There is place for real number, but when the root, but when there's when the root m. So here, if m is a negative number,
Very good.
it comes under the complex number, which is not a real number, and it is completely opposite of it.
Yes. So there is no space on the number line, so you cannot represent then. But as of now, until m is restricted to natural number, you have very well you can define it on the real number line. Okay. Great, great, Nirvigna. So, can we proceed to the next one now? Any doubts, Sridatri and Rahi? Any doubts? No? Chalo. So, now the third one. Every real number is an irrational number. Every real number is irrational number. Is it true or false?
False, ma'am.
False, right? So,
No,
real
false.
number, you also have rational number in real number, but rational is not irrational. So real is not irrational. Every irrational can be real because this is a part of real number. But you cannot say that every real number is also irrational. This is a bigger set. Okay? So that is false. So now question number 2. Are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. So you tell me, already I have written multiple examples here also. So you tell me, are the square roots of all positive integers irrational? If I take the square root of any positive integer, this is irrational. So they are saying, if I take the square root of any positive integer, are all the square roots irrational only? Or do you get any rational? If you get a rational, can you give me an example? Simple. Yes?
False.
False.
Ma'am, it's
No,
false.
no true or false. True or false are done. Now they are asking you to give an example.
Ma'am, root 9, this is 3.
Excellent. So root 9. Square root of root 9 is rational. Can you tell me the answer, Rahi, for root 9?
3, ma'am.
Very good. So root 9 I can write as 3. 3 is a rational number. So square root of every number need not be irrational. Few may be rational as well, like root 16. Okay, so this is also rational. So few examples you can list it out. Okay, clear? Chalo. Now moving on to the actual concept of today's session. So the last topic, the third question. So show root 5 represented on the number line. Before that, I want to teach you the concept. Then we shall move into the question. Okay. So fourth is just an activity. So I will just leave it for you. So you can do it if you are interested. Otherwise also you can just leave it. So here the topic for today, the most important topic is representing irrational numbers on number line. So as I have been telling you from the start of the class that we have been representing rationals on number line, but today we will learn how to represent irrational number on the number line. Okay, for this we shall take the help of the great mathematician Pythagoras. Okay, so he will be helping you all throughout your 10th class, so never forget him. Okay, so this is the start, but he will be helping you all throughout your 10th class. So each and every problem, wherever you see a right angle triangle, you should immediately remember about Pythagoras. So what type of triangle is this? Forgive me for my drawing, but I hope you can guess. What type of a triangle is this?
Right angle triangle.
Very good. So in a right angle triangle, so you know every right angle triangle will obey Pythagoras theorem. Yes. So can you state what is Pythagoras theorem? Okay, let me state it for you. So I think you have learned in your okay. So you might have just read about it. Okay, so I'll state it for you. Just see the side opposite to this 90-degree. This is called hypotenuse, isn't it? Yes, this you know the side opposite to 90 degrees is called hypotenuse, and these are called the other two sides. Okay, the base and the perpendicular I can call simply, and this is the hypotenuse, which is the longest side. Hypotenuse is the longest side. Okay, longest side in a right angle triangle. So what Pythagoras says is the hypotenuse square. Suppose if this is ABC, I can see AC is the hypotenuse. So he says the square of the hypotenuse will be equal to the sum of the squares of the other two sides. Okay, if I take the square of this hypotenuse, it should be equal to the sum of the squares of the other two sides. For example, let me give you an example. This is valid for every right angle triangle. Okay, you can check it out for any right angle triangle. This statement will be valid. So this is 5, 4 and 3. Okay, so can you identify the hypotenuse from here?
Sorry, ma'am.
Great. So 5 is the hypotenuse, the longest side, and also the side opposite to the 90-degree. Okay, so 5. Great. And 3 and 4 are the other two sides. So he is saying that this hypotenuse square is equal to the sum of the squares of the other two sides. Other two sides are 3 and 4. Square it and sum it. Okay, so this is 25 as you know. Here you have 9 and this is 16. So adding you will get 25 here also. So as you can see, hypotenuse square is equal to the sum of the squares of the other two sides. Very important, very important even for your class 10. Class 10 without Pythagoras, you cannot take a step forward. Okay, so important. Please make a note of it. So I think you don't know about this till now, but please make a note of this. Done. So you basically understood, right, what is going on here in Pythagoras theorem? Yes. Did you all understand? Now suppose I give you so I tell you that this is 5, this is 12. Can you find this then, this side, using Pythagoras theorem again?
Yes,
Try.
miss.
Yes. Please try and give me the answer.
169 is right.
169 is a square. So it should be the root. Check your calculation
113.
once. 13.
113.
Perfect. Perfect. So it should be 13. So see here. We know that this hypotenuse square, okay, this is the hypotenuse. So I know this square of this. Okay, so let me just name it. So I know AC square is equals to AB square plus BC square. Okay, this side square plus this side square. So that is 5 square plus 12 square. So 5 square means 25 plus this is 144. So 169. But this is AC square. So AC would be root of 169. So that would be 13. Okay, so this side is 13. Now, when you're able to find this side, now similarly, can you find the other two sides also? In any side missing, can you find? If I give you two sides, can you find the third side using this theorem? Simple calculation, the same formula you take. So you may have to interchange sometimes, but then you will be able to find the answer. For example, if I give you this as 7, this as 4, please find this side. You may get it in square roots, don't worry. Just tell me the answer. Let me take it as PQR. Got the answers?
Mom, I got the answer.
Okay. What is the answer you're getting?
Mom, PQ is equal to root 65.
Okay, so let's check better. So we know that PR square, hypotenuse square equal to PQ square plus QR square. Okay. PR is 7. So 7 square is equal to PQ. We don't know. That is what we are going to find it now. Plus QR is 4. So 4 square. Now, this is 49 is equals to PQ square plus 4 square is nothing but 16. So PQ square is equals to the 16. Just transpose it to the other side. So you'll have 49 minus 16. So it is 9 minus 6, 3 and 3. So this is PQ square. So PQ would be under root of 33. What was your answer, Ahi?
Mom, I said it is root 65.
Okay, so I think you added. So you added 49 and 16. See?
Yes, mom.
Right.
Yes.
So when you're transposing to the other side, beta, it needs to be subtracted, right? Okay, so that's the mistake. But otherwise, did you understand the concept? Yes? And Nirvignya, did you get the answer?
Yes, ma'am, I got the answer, but I was scared it would be wrong, so I didn't tell.
No problem, no problem. Okay, Dhatri?
Yes, ma'am, I got 30.
Great. Root 33. Don't forget the square root. It will change your answer completely. Okay? Chalo then. So this concept is clear, right? So let me ask you, if it is 1 here and 1 here, can you tell me what is the value here? Very simple.
Ma'am, 1.
1. Check it again. So all three sides cannot be equal beta. This is the longest side as we have learned. Hypotenuse is the longest one. Why so long?
Ma'am, 2.
2 or root 2?
Ma'am, 2.
2?
Ma'am, root 2.
Root 2 is the correct answer. Okay, so that's why I said never miss the roots. So for example, if I'm taking it as ABC again, I'm doing the long procedure again. Okay, so just concentrate. AC square is equals to AB square plus BC square. When you're habituated, you can directly write it as root 1 plus 1. Okay, but as of now, see the entire steps which I'm following. Okay, so that is equals to, this is 1 square plus 1 square. So 1 square plus 1 square is 1 plus 1 gives you 2 here. Agreed. But this is AC square. Now what is AC? Got the point? So AC has to be root 2. Okay, so this is root 2. Also, suppose if I have root 3 here and 1 here, can you tell me what is this value? We are actually into your syllabus now. If you see root 2, root 3 are nothing but irrational numbers. So with the help of this concept only, I'm going to represent it on the number line. So I want you to be perfect with this. So you have to guess what should be the other number. Accordingly, you can represent on the number line.
Ma'am, I got the value.
Okay, what is it?
Ma'am, 2. Normal number 2.
Okay, please check it again. Halfway correct, missing on something. Okay, all three of you look here. So let me explain. So PR square, hypotenuse square is equals to PQ is one side, square of it, plus the other side is QR, square of it. So I have PR as root 3. Okay, so square of it I have to do is equals to PQ is 1. So 1 with a square over it plus QR square. So root 3 whole square gives me simple 3. Square and square root gets cancelled. And I have 1 square is 1 plus QR square. So transposing 1 to the other side, 3 minus 1 will give me 2 is equals to QR square. Now I need QR value. So QR would be square root of 2. I got it. So somewhere you missed your root. Okay. So was Nirvigna and Sridharti able to do? Were you able to do? Dhatri, I'm not able to hear you.
I got confused near the root. I did till root 3 whole square. I got
Okay, so calculation part. Yeah, no problem. So this was root 2. Okay. So basically representing root 2 on number line, root 3 on number line. Now your textbook question, what was it? Root 5. So that root 5, I would like to take it on the hypotenuse here and I will write a 1 here. Now tell me what should come here. Same process.
Mom, I'm getting 2.
Excellent. 2. Good. So once you get the answer, you can also check it. How do you check it? See. So 1 square, this side square, 1 square, plus this side square, 2 square. It gives me 5. Okay. So 5 is nothing but square, this side square. Got it? So if I take root, it will be root 5. Okay. So that way you can check it out quickly. So as of now, I'll tell you the whole process. So suppose if this is xyz, so you know xz square equals to xy square plus yz square. So root 5 whole square is equals to 1 square plus yz square. Yz you have to find. So 5 root 5 and square of it gives me 5 equal to 1 plus yz square. So transposing this would be 5 minus 1, 4 equal to yz square, and yz would be root 4. So that is nothing but 2. Got it now? Okay.
Ma'am,
So
I got the correct answer.
correct
Now.
answer. Great, great, beta. So if this session ends, this will end in 1 minute. So please rejoin the session using the same link. Okay. Chalo. So as of now, I have 3 triangles here. I think you have already done it in your notes. So let me take the first one. This was root 2 and this was 1 and 1. Then the next one, this was root 3 and this was 1 and root 2. And the next last triangle was root 5, and yes, this was 1 and 2. So why have we done this entire procedure? So that you don't by heart the answer given in the textbook. You understand why are we drawing the number line in such a way. Okay, so we are basically using Pythagoras theorem here. So that theorem satisfies for every right angle triangle. So that way I'm going to use the theorem to represent root 2 on the number line, root 3 on the number line, and root 5 on the number line. Okay, so I'll tell you how to convert this on the number line. If the session ends, you will join the session using the same link. Okay, so firstly, let us learn root 2. So I took a number line and starting from 0, 1, 2, 3, a basic number line. Now, what do you see here? This side is how many units? 1 unit.